The degree to which this technology will be closer to the utopia that we imagine versus the dystopia of Hollywood narratives is really up to all of us.
Welcome to How AI Happens, a podcast where experts explain their work at the cutting edge of artificial intelligence. You'll hear from AI researchers, data scientists, and machine learning engineers as they get technical about the most exciting developments in their field and the challenges they're facing along the way. I'm your host, Rob Stevenson, and we're about to learn how AI happens. To work in AI is to be surrounded by possibility. You'd be hard-pressed to find an AI application without revolutionary and disruptive potential. So, now that you're an AI expert, how do you even decide which world-changing future you want to spend your time bringing about? Today's guest is a true AI powerhouse. Dr. Eric Daimler has spent 20 years in the field as an entrepreneur, investor, technologist, and policy advisor. He's served as the assistant dean and assistant professor of software engineering at his alma mater, Carnegie Mellon University, where he earned his PhD in computer science. Dr. Daimler has co-founded 6 technology companies, including his current one, Conexus. He's the author of the upcoming book, The Coming Compositionality, the roadmap for using technology to solve society's biggest problems. And he served as the Presidential Innovation Fellow for the Obama administration. He assured me that Air Force One is every bit as cool as you think it is. Given Dr. Daimler's storied background, I wanted to learn where he sees massive opportunity in the AI space, and how he decides where to point his expertise next. In short, his answer is the principle of compositionality. But I'll let him tell you why.
I was influenced not only by the time I've spent in and around artificial intelligence and its various expressions, but certainly the time I spent in federal government and during the Obama White House. That was really a different perspective around AI, where I saw the limitations of these grand plans, both for organizations the size of the US federal government and also very large commercial expression. So I came to the conclusion that the limitations of AI were manifesting themselves in ways that were not appreciated. I think that people have gotten the memo about collecting data. The phrase, the data is the new oil or some such thing. People understand that, and they've been collecting a lot more data. But it really feels like there's a misinterpretation of what that even means. What I didn't intend is for people to give me timestamps on US equities at the second level or millisecond level, where it previously was at the minute level. Just to use an analogy, we have high frequency trading in equities and we've solved that problem, but you can create data that doesn't really add more fidelity to the knowledge you're looking to gain for better business decisions. And that's one of the limitations that I saw expressed at the government and other large organizations. What I saw was that many organizations were collecting data and then storing it in strange ways that didn't comport themselves to what the business actually needed, getting knowledge, getting wisdom. That's what I'm working on right now. I found a research project that happened to have gotten funded by the U.S. Department of Defense and the U.S. Department of Commerce simultaneously to solve 2 very large problems that were deemed to be intractable at the level of computer science. I started working with this group once I got out of the White House and began to put money into it personally to explore what it could be as a business. Then we have turned that into something that's commercial, and I think can help fulfill on people's expectations around AI. The bringing together of large heterogeneous data infrastructure to allow for better business decisions.
When you say the approach to AI was different, or the perspective on AI was different, was that a matter of scope, of thoroughness? What was the difference between your previous experience and then the White House experience?
I am grateful for spending time in and around AI from the perspective of an academic researcher at Stanford, at Carnegie Mellon, University of Washington, Seattle, and as a venture capitalist on Sand Hill Road, as an multi-time entrepreneur. But my time in policy gave what you just said, Rob, is a bigger scope. It gave a broader visibility about these really, really large problems. Sometimes they're organizational, sometimes they're technical, most often they're both. And I just got to see these circumstances, terrible stories up front where breathtaking amounts of money were wasted from doing ETL processes that are terrible in all respects. They're terrible for the individuals having to execute them because they can be vocational level IT work for people often with graduate degrees in computer science. They're often, terrible for the investors and board of directors of the client company because they can most often produce disappointing results. And then they can be frustrating in the whole IT team because the results are often frustratingly fragile. It's part of my training as an engineer that I like to solve technical problems, but I like to build it and then have a result that I can be proud of. ETL processes are just not that. They're just often these long slogs that cost a lot of money with large teams that often produce these results that need to then be redone as soon as the world changes. You add in the idea that companies may not just acquire or divest of assets, but you add in the idea that technology is evolving all the time and that I might store some of my data on SAP and other on Oracle and any number of other cloud infrastructure combinations, and it just becomes a mess and it's no fun. The infrastructure that supports AI is often ignored. You call it data engineering because these terms kind of change around a bit, but in that data engineering infrastructure, the jobs are bad, they're unpleasant, and they are limiting what the AI researchers can accomplish and the AI professionals in a commercial expression can accomplish. It's helpful for us to always remember, what's the point of us using these learning algorithms? What's the point of our deployment of these systems? The collection of data, the processing of data, the execution of a decision, and then learning from it. What's the point of these things? The point of these things is to make everyone's lives easier so that we really don't have to think about it much. We kind of put that sort of stuff in the background a little bit. It should make our lives kind of less stressful, more enjoyable. Let us do things that are more human that we really want to do. That all gets lost when the collection of the data itself comes into question, or the collection of data itself becomes a burden, either being a pain or unpleasant, or become costly, fragile, or unpredictable.
So this is the chief problem you are addressing with your current company, Conexus. What is that outcome? You said you are outcome oriented. You like that payoff of solving the problem. When you think of big picture, what problems that you're hoping to solve with Conexus's implementation, what does that look like?
What Conexus is working to do is solve the problem of compositionality. As an abstraction, compositionality is a wave that's going to take over the next 10 to 20 years of IT infrastructure. The term compositionality that Conexus addresses is often confused with modularity. So people can often think of modularity as Lego blocks. This gets confused in the discourse quite often. Gartner actually messes this up. Gartner is not a good source of truth in this regard because they did a report on compositionality, and really they could have just put it in the headline. Compositionality is modularity. Whoops. They just made that mistake. Compositionality is fundamentally different in that modularity, the Lego blocks plug and play, is analogous to a train where you can swap in and out boxcars as often as you'd like. They're generally interchangeable, but you can only make a train so large, a couple miles, say. But compositionality says that I can do that regardless of the state, essentially meaning scale. So whether the train is 100 meters long or a kilometer long, it doesn't matter. I can keep adding. In that analogy, the train would be modular. The train system is compositional. It's that sort of infinite building block expression that is the future of our world. And you see some beginnings of this. You just don't read about them because they're not terribly sexy to talk about. One example is smart contracts. Ethereum and all Ethereum's competitors on the blockchain, those actually would not be possible without the level of mathematics that expresses compositionality, type theory, categorical logic, categorical theory. Those branches of mathematics are demanded to even enable smart contracts to exist. Another example is quantum computers. It's certainly sexy to talk about qubits and everything else around quantum computers, and I'm as fascinated about that stuff as anyone. Those wouldn't be able to exist without that same level of math. And specifically, you can't prove the efficacy of a quantum compiler. That's how it would happen. You can't prove the efficacy of a quantum compiler without type theory, without category theory. So that's a way in which quantum computers wouldn't exist without this level of math. That's compositionality. You actually need this level of math to prove whether or not these compositional systems are doing what they say, are as effective, are as stable as intended. You have to have them because we can't interpret quantum compilers. We can't program in any other way smart contracts. You can even say Minecraft is compositional because it's infinitely self-referential. It's this whole other universe that expands in infinite ways in every dimension. So in some ways, Minecraft is compositional. And in that sense, you'll begin to see compositional systems beginning to emerge all over. They are not themselves infinitely compositional, but they are beginning to be compositional. So the media ecosystem is an example of this, where it's completely self-referential, and you can begin to add in little parts to it. The distinguished from modular is that it can be infinitely growing in multiple dimensions. Those little parts will become automated over time, and then it'll become truly compositional, like a smart contract, like a quantum computer compiler, or perhaps Minecraft, if that's either the result or some intermediate step. That's the world, is compositionality. That's where we're going, and the math that supports that, type theory, categorical logic, that's really going to sweep away everything underneath IT infrastructure over the next decade or so. That's where the world's going. That's what Conexus addresses. We are not the only ones doing it, as I'm describing. We just Conexus happens to be the leaders in the enterprise software expression of this discovery in math, specifically that in bringing together databases. So Conexus brings in databases in a way that makes them useful for colleagues executing on AI projects.
I'm really interested in the mathematician layer of the AI practitioner. It's come up a handful of times, and if compositionality is the future of the space in a lot of ways, as you say it is, at least in the IT infrastructure area, it sounds like having a grasp on some of these more advanced, even frankly, compared to geometry, for example, newer math, is an important stack in the AI practitioner's skill set, right? An important toolkit in the tool belt. Would you agree? Do you think having a deep understanding of some of these new and more advanced branches of math is crucial to achieving AI mastery?
Something I can talk about in my career around AI is that I balanced trying to find out what was interesting to me with how I'm growing as a professional, what skills I need to acquire, with the changes in the world. What is going on in the world that is now demanding maybe a new composition of skills. So to your question generally about what is the future of an AI skill set, it's difficult to predict in some respects. I want to be careful about how much prediction I give for that. I couldn't have predicted 10 years ago, 20 years ago, maybe 20 years ago, the increasing importance of statistics and probability that we might have today. I couldn't really have predicted the decline of geometry, trigonometry, and even calculus in its relevance. So if you might say the more math, the better, but you frame this out pretty well, Rob, which is categorical logic, type theory, categorical algebra. If I was to choose, I would replace calculus, trigonometry, and geometry with category theory, and statistics and probability. They're more relevant math to the 21st century. They're more relevant math to a digital age. The place where you see the math of continuity, calculus, is still to be found in applications such as mechanical engineering, aerospace engineering, but really just less appropriate to the applications we see today. Relational databases were built on relational algebra coming out in 1972. That's just not great for us in 2022 when we're talking about trillions of attributes along trillions of data sources, each of which are expanding quadratically year over year. It's a really different world. You have to be thinking at a level of abstraction that a couple of million, maybe even a billion data points didn't quite demand. At the trillions of data, trillion data sources, each growing quadratically, what we need is category theory.
I like how you framed your approach as, the center of the Venn diagram between what I'm really interested in and what is sort of in demand or coming about in the marketplace currently. For you then, the middle of that Venn diagram, is that the disruption to the IT infrastructure that's happening with compositionality? Is that sort of the sweet spot between what you're really interested in and what you think are the problems of today and tomorrow?
I'm working with my two fantastic co-founders on the promise of compositionality. It is what we think is in the future for us and for a greater IT infrastructure. We think that part is inevitable. There's really no other pathway we can envision that somehow limits the impact of compositionality and the math that supports compositionality. That's why I'm here. That's why my co-founders are here. That's why our team really gets excited about the future that we are creating. We think this is really foundational. The timing at which this is going to impact people that aren't experts in the art, who knows? Whether it ever enters common nomenclature, who knows? But this will be foundational for all aspects of IT infrastructure. Calculus is going to become, and relational algebra, all that, it's going to become a little bit like Latin. It'll still be interesting, it'll be useful, but people don't really talk about Latin much, except when they talk about their bonus. I think that some of that math is just going to become less and less relevant. We need to prove compositionality, and the reason we need to prove compositional systems is because the world is becoming more and more complex. How it's becoming more complex is that people are trying to add in their own knowledge. The future I am super excited about for the average person in an organization, because very soon they will be able to, every one of the people that find themselves in a large organization will have new sets of tools to be able to express business rules, will be able to express their own knowledge, will be able to express their own subject matter expertise inside of a framework that can then be applied or removed as the needs require to be part of better business decisions. This isn't possible today. Many jobs are currently just a constant series of rather low-level decisions. They're not actually taking advantage of people's expertise because they're often just too nuanced, and the training for most of us hasn't required a level of thinking about exactly what we're doing or exactly what we want to have happen. That's exciting and a little scary because that'll be the retooling of skills over the next decade, is that all of us will benefit from thinking more carefully about what we want to have happen and exactly how. The example in AI is that classic problem about the automated car coming across a crosswalk. Does it stop, slow down, keep going when it's a shadow? Is it a person? Is it a tumbleweed? What percentage of the probability is the system comfortable with that decision? Ultimately, as a society, we will need to make a decision around the liability for that decision. Does it sit with the programmer? Does it sit with the manufacturer? Does it sit with the driver? That level of specificity has yet to enter public discourse broadly. That type of clarity of decision is going to show up more and more throughout large enterprises. So when my company, Conexus, was looking during the pandemic for a client, they asked, where is my personal protective equipment? Where is my PPE? And it was funny to think that, these companies with 100,000 employees and 1,000 ships, each one of which has 10,000 containers on it, that they couldn't immediately find out, oh, hey, it's in the ocean and it needs to go to Houston or Hanoi or whatever. These sort of decisions took a couple of days. There was some friction involved in these decisions. And that's because there hasn't been the systems to capture all of that knowledge in a way that's then easy to integrate with other systems that then could engender a business decision upon which the organization could execute and allocate resources. Often those are just done in Excel. The list of items in a particular container on a particular ship in a particular fleet. That's evolving, but I'm describing the way in which it's evolving and the dynamic that supports that evolution, which is not merely the digitization of data, but also the reliable, guaranteed integrity of the semantics integration of that knowledge that's acquired across a larger organization. That's the future, and that's going to be an exciting place for people comfortable with clear thinking and clear decision making to be working over the next decade.
When you say the retooling of skill sets, do you mean allowing workers to focus on high leverage activities, things that are more judgment calls, things that only a human can do, and automating sort of like low leverage decision making? Is that what the retooling is?
There's often a discussion about humans being able to work on their own empathy. And that's true. The degree to which people are effective in collaboration with others or in discussion with others, that is definitely a skill set that other people have talked about, and I would encourage. The type of human attributes that are just difficult, if not impossible, to replicate in a computer are absolutely the future. I am describing a different part of the work equation where we are all part of large organizations, and we need to think about how we want work to be expressed inside of these large organizations. Conexus is working with a large energy company. They have tens of thousands of employees. These employees have particular functions to maintain the safety of the discovery and the distribution of energy broadly. There is certainly something to be said about each one of the people inside of Conexus's clients expressing empathy with each other in order to be more effective. But there is a day-to-day responsibility over the next decades to distinguish exactly what it is in their jobs that they need to formalize, or you'd say automate, or just to distinguish in order to be able to work with more reliability to a broader system. What's often missing in artificial intelligence deployments is this sort of appreciation that the current state of the technology, exploring the subset of ML, which is deep ML or deep learning and neural networks, has become a sort of religious argument that people are going down that hole because it's sexy and interesting to be sure, but also just because of the momentum over the past decade from these often not terribly practical applications, and that there is a lot to be gained from going back up the stack towards more basic machine learning techniques and even deterministic AI, and the other often neglected subset of artificial intelligence. I am personally of the belief that many of the most sophisticated applications of AI over the next decade will use a combination of probabilistic and deterministic AI. I think at the board level, it is very important to at least have that awareness that this is a possibility. And the reason is manifold, but I'll take just one, is that when you're talking about probabilistic outcomes in ML, in neural networks, you're talking about systems that are not really by their nature 100% fault tolerant. If you have probabilities, that means, by definition, there is some probability of failure built in there, which is fine if what you're talking about is applications in digital advertising. But if you have contexts that are life and death or other similarly catastrophic events for an organization, relying on probabilistic outcomes is often just not where you're going to need to end up. The testing and repeated testing of automated vehicles is a good use case here. You see outside my office, you see Ukes cars driving by every couple of minutes with Waymo cars in pursuit, I guess. That those will not, there's an argument to be said, will not be satisfying to safety authorities or to a driver at even 1 trillion miles of testing. It's synthetic data creation, for which there's some great companies being built and commercializing results, is not the final solution to that problem. These are all possible solutions. They could be pathways to solutions, but you think that commercial airline manufacturers have done much of this before, and yet airplanes fall from the sky. People die. And the way to solve that problem when you're talking these life and death contexts for commercial airplane manufacturers or in energy exploration where the consequences of failure can be disastrous is to bring together the sensibilities of probabilistic AI and deterministic AI. It's in deterministic AI that we can guarantee integrity of the semantics, the integrity of meaning across a heterogeneous data infrastructure. That's what I've seen. What I've seen at Conexus is that we find value, our clients find value, us being able to prove that this hard-earned knowledge across a large organization is preserved as it moves across an organization. What's worse than to have a lot of effort be put into capturing the knowledge and the wisdom on top of the data that's collected, but then not be able to trust that that's going to be not misinterpreted as it moves to another context of the organization. That's just a terrible waste of we'll say, organizational energy.
When you say that the public, the market, wouldn't be satisfied with, for example, 1 trillion miles of data, synthetic or otherwise, is this like a marketing problem? Is this a messaging problem? Or do you think in the case where AI is being used to make decisions that are life or death, it needs to be perfect, or does it just need to be marginally better than a human in the same scenario?
This is a great question, Rob. This gets to my motivations for even being in this business. The issue about whether something's a marketing problem, I think we might characterize differently, because us humans are not really rational in general, often, and we are especially bad around probabilities. So if we present to the general public, hey, I have a automated vehicle here that is 95% accurate, plus or minus 7%, they'll say killer robot. And then you think, well, hey, do you know what your own efficacy is as a driver? People will completely miss that point. And even if you tell them their own numbers of the probabilities of getting injured in a car, per mile or per drive, they don't care. They don't care, right?
Or they're like, I'm a safe driver. It wouldn't happen to me.
Yeah, exactly. So for a variety of reasons, I don't think this is so easily dismissed as merely a marketing problem. We have to, and my motivation is, to communicate with the public in a way that gets them involved in the conversation. And so it's not just selling them, it's having them be engaged. The next decade is going to involve a lot more people doing traditional AI-ish jobs. Something that happened when I was in the federal government is that people were holding some technical leadership positions, did not have technical degrees. And some people might be disappointed to hear this, but it's really the nature of the world we're going to be living in. Is smart people, well-meaning people, are gonna be making judgments across technical teams, across technical infrastructure. That suggests that we need to have a bigger conversation across society about what we want these technologies to look like. For Conexus, what we do and how we express it is Conexus makes sure that we don't even see metadata. We don't see data. We don't see metadata. We let organizations bring their databases together in a way that guarantees semantics, in a way that guarantees meaning. But for many, many organizations, we will need to have a larger ethical conversation, a larger moral conversation about how we want data to be collected, redistributed, or merged, or discarded. So those are non-technical people, but having a conversation in a technical context of AI systems, if I will. What I want to do is make sure that we have a society that is comfortable with the technologies that are being introduced, such that they get embraced. I want these technologies to be welcomed, not resisted, because the technology often can save lives. The technologies behind automated cars are being introduced into cars you and I buy. And my car has these fancy technologies keeping me in the lane, making sure that I don't crash into the car in front of me in traffic. Those are fantastic. It makes my drive much, much more pleasant. I want to see those embraced by a large part of the population with enthusiasm. Because they save lives, they also have another side benefit, which is they will encourage the further development of these life-saving technologies, which then has a fantastic virtuous cycle for the maintaining of, we'll say, Western civilization, relative to Western civilization's competitors globally. Companies go where the customers are. And if we have customers in Western civilization that encourages the adoption of this technology, then we will have companies that generate those technologies, and we will have the concomitant benefits from that adoption.
Interesting. So you view the gap between AI right now and AI being ubiquitous and accepted not as a factor of where the technology is, or because there hasn't been enough of a ad campaign, a public service announcement, trying to whip up support for this. You think it's about bringing people into the process and making this a slate of technologies developed beside the people it serves to build products for?
I want to speak about this technology at the right level, to the right audience, at the right time. There is a time to be talking about doing queries on Postgres that can import or data stored in Oracle. That's fine. But the general public is going to get tired quite quickly of our own fascination with our own brilliance if we talk too much in the weeds about how this data gets implemented. What the general public cares about is what this technology means to them, what it can provide, what the benefits are, and how they can be sure that the benefits are actually being expressed. One of the frustrations I have about AI regulation and proposed legislation is that it is not addressing some really low-hanging fruit that can address some concerns for the general public. And this issue can be relevant for technologists developing this infrastructure. One is the engagement of circuit breakers in this technology. The development of some of these automated technologies can be linked to other automated technologies. It doesn't mean that it should be linked just because it can be. And I appreciate that everybody is working on their own quarterly incentives with their own product managers. So really there is no Meta, there is no Twitter, there is no Apple. There's just a whole bunch of teams with their own quarterly objectives, right? But all those teams might just think about how these automated systems can be broken up in individual compartments, so that we can get some human interaction. The good example here is my car. My car, as it's driving down the road, it will occasionally ask me to intervene, is what my car says. Driver intervention necessary. Right? That's a type of circuit breaker. Right? It's essentially saying, hey, I'm comfortable, but now I'm not comfortable. I was comfortable, now I'm not comfortable. So you take over. Those sort of circuit breakers where just humans are going to touch an automated system is really helpful. Another example about that is that I like many people during COVID was reassessing our own housing situation. So I was just looking at houses. If I just inputted, I work at Conexus, and then a list of houses appears, I would say, what happened in the middle there? You took my income and my credit score and then determined what I could afford. I want to break that up a little bit. Or I go to the doctor with a pain and the physician says, oh, hey, here's a drug. It may have some side effects. Like, I want to say, hey, well, what was the chain here? What was the decision point in here? I want to have some agency in that sequence. So the first part is circuit breakers. The second part is an audit. Now, we need to find a better word for this, because audit and oversight can give people bad feelings, sometimes correctly. But the big efficiency that we gain from automated systems might benefit by being managed slightly by experts in the art, taking a look at the data models and the degree to which they are doing what's intended. So separate the data from the data model, and then let experts, outside individuals that would be appropriate for such things, evaluate the degree to which all algorithm is doing what it claimed to have done. Use a zero knowledge proof if you want, or actually just investigate the actual code of the algorithm. But that's the second part, is do a sort of oversight or audit, separating the data from the data model. And then the third part that we need to all implement for the regulation of algorithms is lineage and provenance that's guaranteed. So often when data is normalized, when it's integrated across, we used Postgres or Oracle database, the earlier example, or any sort of kind of heterogeneous data infrastructure, the fidelity of the underlying meaning often gets lost. We had one example where we were working with Conexus was working with a hospital group, where one group talked about diabetes and the outcome is yes, no. Another talked about diabetes in the same hospital group, diabetes, how are we treating it? I don't just want those to be normalized and have that fidelity be lost. This happens for us with clients in drug trials. It happens in the logistics companies. I want that fidelity to be guaranteed, to be maintained. So that's lineage and provenance. I want to know how that data actually came about. So circuit breakers, oversight, and data lineage. Those are the three ways that I would institute a regulatory regime around AI and around algorithms that I think will engender trust among the larger population.
Engender trust, and also build tools worthy of this technology, build tools that kind of bring about are fair, that are understandable, that don't perpetuate biases and some of the nastier things about human nature from our past, right? Super, super crucial. Before I let you go, Dr. Daimler, I want to put it on you to tie a nice little bow on this episode. What can AI practitioners do in their daily work, in the way they structure their careers, to ensure that the way they're using their skill set and the tools they're working on bring about a better future?
I really admire those that can be self-aware enough to look around about how their technologies are implemented in the real world. I think there are some real opportunities for technologists to engage in the conversation with non-technologists about what's possible and what's not possible. There are people that may not be experts in the art that, with good intentions, have a difficult time looking at a problem as hard, and they might think it's easy, or looking at an easy problem and they're thinking it's hard. I think it's the job of technologists and those that are studying this field every day to engage, so that those that are looking to help deploy this technology in real world environments can understand what's hard and what's easy, so that we make the appropriate trade-offs. I can give an example here where the City Council of New York City voted to implement this requirement to expose the automated algorithms behind resume screening. It's just the most ridiculous legislation, because first of all, the idea that somehow if it was computer automated is offensive, but if it was done by 2,000 humans, it's not, kind of fundamentally misses the point about what this technology does. So we need to engage with others that are scared about these automated tools to bring out exactly what are the concerns. Exactly what do you want to have happen? Exactly what are you concerned about? Bias can show up in a lot of different ways. For an example, it can show up in all the ways we know about with data sets. It can also show up in the absence of data sets. So Conexus had a customer that was working on ESG reporting, environmental social good reporting. And we found from our client, Conexus did, that we had a lot more data available in developed countries than developing countries. That's a type of bias that would skew further investment in these technologies as we report, or our clients had the good intention to report. So these are conversations we all need to be part of. We can't just allow for non-technologists to accept or reject our technology. The degree to which this technology will be closer to the utopia that we imagine versus the dystopia of Hollywood narratives is really up to all of us.
Dr. Daimler, this has been a fantastic conversation. Thank you for being here and for your time and for sharing your expertise. I've loved chatting with you.
Thanks, Rob. It's been great.
How AI Happens is brought to you by Sama. Sama provides accurate data for ambitious AI, specializing in image, video, and sensor data annotation and validation for machine learning algorithms in industries such as transportation, retail, e-commerce, media, medtech, robotics, and agriculture. For more information, head to sama.com.